everybody, this is Miss Phoebus and I'm back again with some more ancient Chinese mathematics. You've watched a couple videos on the history of Chinese math and some matrices stuff. So what we're going to do is we're going to look at the assignment. We're going to be multiplying matrices. If you have a graphing calculator, which you do on the Chromebook, you could multiply these in the calculator. But what I'm going to do is I'm going to teach you how to do them by hand. So when multiplying matrices, the number of columns in the first matrix has to be the same as the number of rows in the second matrix. So if we are multiplying a 2 by 3 with a 3 by 1, we are going to be able to multiply them because these numbers right here, they match. If those two numbers are different, we cannot multiply them. Because those numbers match, then the size of my answer is going to be the number of rows from the first matrix and the number of columns from the second matrix. So remember, it's rows by columns, rows by columns. So then we're going to create, in this case, a 2 by 1 matrix. So multiplication of matrices is not commutative. So let's say, you guys know that 2 times 3 is the same as 3 times 2. But let's look at, so we had this 2 by 3 matrix on the left, 3 by 1 matrix on the right. Let's flip-flop them. Let's do the 3 by 1 on the left and the 2 by 3 on the right. So then I'm looking here, and are those numbers the same? No, they're not. So if this is matrix R, this is matrix T, I can multiply R times T and be okay, but that is not the same as trying to multiply T times R. That's not going to work. So that's what I mean by the multiplication of matrices is not commutative. So before you actually try to multiply two matrices together, you should check their sizes and make sure you can multiply them. So I can't multiply these two matrices, C and D, because C is a 4 by 2, because C is a 4 by 2, and D is a 3 by 5. So I can't multiply them together. So if I was asked to do that, I could say that the answer is undefined. Anytime I am unable to add two matrices because they're not the same size, or multiply two matrices because they're not the correct sizes, I can say that the answer is undefined. Now, I can't just say that for everything, but I can say that a little bit. All right, so the question is it defined? Can I get an answer? Or is it undefined and I can't get an answer? So we're looking at the sizes. So matrix A, matrix B. Let's write the sizes down. So matrix A is a 2 by 4. Matrix B is a 3 by 4. Can I multiply these two together? I'm looking at these two numbers. Are those numbers the same? No, they are not. So this is undefined. If it was, one had a 4 and the other one had a 4, then it would be defined. But those have to be the same numbers to be defined. So defined or undefined? Let's look at the sizes. This is a 3 by 2. This is a 2 by 2. We're comparing these numbers. They're both 2's. This is defined. All right, so I want you to write an example of a matrix multiplication that is undefined. So you're going to write two matrices, and you're going to show me based on their size. So what I would do is I'd write a matrix and put its size underneath. And then I'd write a second matrix and put its size underneath. But when I go to try to multiply them, it's not going to work. So this is part of your lesson assignment. If the expression A times B is defined, so that means that matrix A and matrix B are able to be multiplied, and if A is a 3 by 5 matrix, could you come up with dimensions of B? So what is the size of matrix B so that I could multiply them together? this is also in the lesson assignment. So there are going to be lots of answers. I just want you to come up with one. All right, so we're going to work on matrix multiplication. So the very first step is, can I multiply these matrices? So let's look. This is a 3 by 2. This is a 2 by 2. Can I multiply them? Yes, I can. And so because I can multiply them, then my answer is a 3 by 2. So what I can do is I can go ahead and set up a 3 by 2 matrix. Now, this is not like the addition and subtraction matrices. These are a little bit more intricate. So what we're going to do is we always do rows by columns, right? So we are only going to be doing the rows from this matrix and the columns from this matrix. So it's always rows by columns. So we're going to look at row 1, column 1. We're going to multiply these entries. Now I'm going to show you how to do that. But what we have here is we have row 1, column 1. The answer is going to go here in row 1, column 1 when I'm done. Okay? So I'm going to figure out a single number to put in this location. Let's figure out how I'm going to do that. So it's going to involve a little bit of multiplying and a little bit of adding. So what I'm going to do is I'm going to take the first things and I'm going to multiply them. So tell me about 4 times 5. That's 20. And then I'm going to multiply the second things together. 8 times 9 is 72. And I'm going to add those two numbers together. And the sum of those two numbers gets put in row 1, column 1. So 20 plus 72 is 92. So that is my first entry. All right. Now, you can do this a couple of different ways. I usually stick with row 1, and then now I look at column 2. So now I'm looking here. So then I have to multiply 4 times 2. 4 times 2 is 8. And then I'm going to add to that 8 times 4, which is 32. So what is 8 plus 32? 40. And my answer goes in row 1, column 2. So here's column 2, row 1, column 2. That's this blank right here. I'm going to put 40. Now that I've done both columns for row 1, I'm going to switch and now work with row 2. So it's a little bit more stuff going on. We're going to do column 1, but the multiplying and adding piece isn't too bad. So we're going to do 0 times 5. I love when zeros in a matrix. And then 2 times 9. 2 times 9 is 18. 0 plus 18 is 18. That goes in row 2, column 1, 18. All right, now we're going to switch from column 1 to column 2. All right, so I've got 0 times 2, which is 0. And then 2 times 4, which is 8. 0 plus 8 is 8. That goes in row 2, column 2. So I want you to pause the video, see if you can handle row 3. You should be getting 2 numbers as answers, but actually if you're paying attention to my work, you're actually getting more than 2 numbers. You're ending up actually adding more numbers together, but the result is 2 numbers. All right, so we're going to do row 3, column 1. Row 3, column 1, we're going to do 1 times 5 and get, let's do colors, 1 times 5 and get 5. And then we're going to do 6 times 9. 6 times 9 is 54. 54 plus 5 is 59. That goes in row 3, column 1. All right, then we're going to switch to column 2. And we're going to do 1 times 2, which is 2. And then 6 times 4, which is 24. 2 plus 24 is 26. So there is my matrix answer for the multiplication part. So the bigger the matrices are, the more entries that you have is going to be a little bit more, I guess, tedious. But is it hard? Not really. You just have to remember the steps. So let's see. Can we multiply these two matrices together? Let's check. So we've got a 2 by 2 times a 2 by 2. Let's look at our, can we check? Hey, guess what? We can multiply them. I wonder what size our new matrix is. Can you tell? It's a 2 by 2, the matrix. So let's set up a 2 by 2 answer matrix. So we've got row 1, row 2. Let me go ahead and write that. Row 1, row 2. And then I'm going to put column 1, column 2. So we can practice getting those answers in there. All right, so we're going to do row 1 times column 1. And our answer is going to go in row 1, column 1, right there. So let's see. We're going to do 2 times 4. 2 times 4 is 8. And then we're going to do, oops. 2 times 4 is 8. Plus, and then we're going to do 3 times 3, which is 9. 8 plus 9 is 17. All right, now we're going to do column 2, and then our answer is going to go in row 1, column 2, so it's going to go right there. All right, so we're looking at 2 times 3, which is 6. And we're looking at 3 times 2, which is 6. 6 plus 6 is 12. All right, now we're done with row 1. Let's go to row 2. Row 2 times column 1, and that's going to go right there in row 2, column 1. So I've got 4 times 4, which is 16. And then I've got 3 times 3, which is 9. 16 plus 9 is 25. And then I'll switch to column 2. And we're going to do 4 times 3, which is 12. And then 3 times 2, which is 6. 12 plus 6 is 18. And that is the multiplication of those two matrices. Now the whole circling and underlining the entries here with colors, I usually, like if I'm doing it on my own, I don't do that. I like put my fingers in those row and column on my paper and kind of do that, use it that way. But you can't see that. You can't see me moving my hands and fingers. So I do draw with the colors and the circles so that you can see in the video what I'm looking at. But do you have to draw those every single time? No, you'll be doing a lot of racing. But if you know, okay, I'm in row 2 and you put your finger there and I'm on column 2 in this other matrix and then you just kind of point to those, it is a little helpful. All right, so why don't you try this one? Check to make sure. Can you multiply them? And then try to figure out the size of the answer. And then see if you can work this out. Pause the video. All right, so the size of matrix, the first matrix is 3 by 2. The size of the second one is 2 by 3. So can I multiply them? Yes. My answer is a 3 by 3. So let's set up a 3 by 3. All right, so we've got row 1, row 2, row 3. And you want to have some sort of pattern, kind of like what I'm doing. Like I'm doing one row and then using each of the columns. You want to have some sort of pattern so that you are not just kind of all over the place. You have a logical pathway. So let's do column 1 times, let's do row 1 times column 1. So that's going to be 1 times 2 plus 2 times 7. So that's going to be 1 times 3 plus 2 times 7. 1 times 3 is 3. 1 times 3 is 3. 2 times 7 is 14. 3 plus 14 is 17. So that's row 1, column 1. Let's look at row 2, column 2. 1 times 4 is 4. 2 times 8 is 16. 4 plus 16 is 20. All right, now let's do row 1, column 3. 1 times 7 is 7. 2 times 8 is 16. 7 plus 16 is 23. All right, now we're ready to go to row 2. We've got row 2 times column 1. So 3 times 3 is 9. 4 times 7 is 28. 9 and 28 is 37. And if I'm wrong on any of these, which it is always possible, you never can tell, then you should be writing the correct number in there. I was wrong. 3 times 4 is 12. I'm doing all this in my head, by the way. And then plus 4 times 8 is 32. So that is 44. And then 3 times 7 is 21. 4 times 8 is 32. And that's a what, 53? All right, so we're done with row 2. Now let's do our last row. And then we've got our columns. So 5 times 3 is 15. 6 times 7 is 42. We're going to add those together. 15 and 42 is 57. And then we're going to do row 3, column 2. So 5 times 4 is 20. 6 times 8 is 48. So that's what, 68? And then 5 times 6, so 5 and 6 and 7 and 8. So 5 times 7 is 35. 6 times 8 is 48. So 35 and 48 is 83. So there is my matrix answer where I've multiplied. And you don't need the row ones and the column ones and all of that stuff. You don't even really need to write the sum out, especially if you can do it in your head, but I want you to see where those numbers are coming from. All right, what about this one? This one looks fun because it's got a lot of zeros in that first matrix. So let's see. This is a 4 by 4. That's a square matrix. This is a 4 by 1. Can I multiply them? Yes. This is for a match. So then my answer is a 4 by 1. 1, 2, 3, 4. There we go. 4 by 1. And then let's look at, now what we're going to have to do is we're going to have to actually multiply each row by this one column. We're going to have 4 numbers that we're going to be adding together. So this might be one where you might want to write it out. So we're going to do 1 times 2 and get 2 plus 0 times 5, which is 0. That's why I like zeros. Plus 2 times 1, which is 2. Plus 0 times 8, which is 0. So that's just going to be 4. Now let's do, we did row 1, now it's time for row 2. So anytime when I'm working with the 0, I can pretty much just skip it. So 0 times 2, skip it. That means 3 times 5. 3 times 5 is 15. The next 0 we can skip. And then 4 times 8 is 32. 15 and 32 is 47. All right. Ooh, in the next row, look at all those zeros. All I really need to do is worry about this 5. So the 5 is the third number. We're going to do 5 times, and then 1, which is just 5. So 5 is what goes in that third row. All right, I have 2 numbers in the fourth row that aren't 0. So I can multiply the first one, 6, times 2, and get 12. And then 7, I should be doing in blue, 7 times 8 is 56, so 12 and 56 is 68. There's your answer. So when zeros are there, yeah, the matrix is bigger, but because you're multiplying by 0 and adding 0 doesn't really do anything, zeros are actually pretty fun to work with. Just kind of skip over them. All right, so matrix operations can help you encode secret messages in cryptography. They can help you solve problems that have many different variables or unknown values using matrix equations. So cryptography is where you take a key, like I have here, where A is represented by 2, B is represented by 1, C is represented by 4, and so on, and I can mix things up and change values, but then later on, if somebody has the key, they can uncode my message. And so this is used a lot, especially over the internet. You want to talk about, buying things online. You want your credit card number encrypted. You want to make sure your banking information is encrypted so that somebody doesn't get the key, and then now they can start using your identity and spending money on your credit cards. And when you hear about hackers and things, they usually have some sort of method to decrypt things. And so we're always looking for better and better encryption methods. But there are times when you want something encrypted and then decrypted. So again, that goes back to buying something on the internet. You want to encrypt your credit card number, but then you want Amazon to be able to decrypt it. So they have to have the key for whatever site that they're using to get credit card information. They need to be able to decrypt your credit card number, but have the bad guys not be able to decrypt it. So there's a whole bunch of mathematics that goes behind that, but matrices as well. We can have things like problems where we have 3 variables or even 2 variables. We have, in this case, plums and peaches, and we know how many of each we have, and we know a total weight, and we want to figure out how much one weighs. We can use a system of equations to help us solve that, and in doing that, we can work with the matrix. So let me show you this problem, not requiring you to be able to do it like on your own, but we could write a system of equations. Now let's let how much a single peach weighs, let's let peach be x and plums be y. So if 1 plum and 3 peaches, so we have 1 plum, so 1y and 3 peaches, 3x weighs a total of 750 grams, and 2 plums and 1 peach, so that would be 2y and 1x equals 500 grams. Then with a system of equations, we can figure out what one of each are. If I have 2 variables, I need 2 equations. If I have 3 variables, I need 3 equations to be able to do this. But we can translate this into a matrix. Now, usually what I like to do is I like to run my x's before my y's. But it doesn't matter in this case. What we can create is we can create a matrix that says 1, 3, 750, 2, 1, 500, and do a system of equations on this matrix where we can modify this matrix and actually be able to tell what each value is. And so the matrices are where you're able to plug this into either a computer or a calculator, or graphing calculators can do this, and be able to get and generate an answer. Okay, isn't that cool? So you can solve systems of equations with this. Here's another system of equations. We've got 3 sizes of chickens. How much does each chicken weigh? Now, it's not the only way to work a problem. Matrices aren't the only way. But it is something where if you have a big enough problem, let's say you had 100 variables and you needed 100 equations, and you don't want to do that by hand, you do have a process to feed it into a computer to work it out and let the computer run and get the answer, then yeah, you want to use a matrix because that's in the language that computers talk. So, anytime you are working with things that you don't know, you know, matrices are helpful. There's another one. We got a cat, a dog, and a bunny trying to figure out how much they weigh. So there's all kinds of problems like this where it could be real life. Now, could you get the cat to sit on the thing by itself and weigh it? Probably. But, these things where we don't know something, matrices can be helpful. All right, so that is it for matrices. What we are going to be doing is we're going to be looking next week at, we have one more lesson on the abacus. So just keep in mind, in design math, we usually build and do things. It's harder since it's COVID time to be able to do that. So in the past, we have built our own abacuses and played around with them. We're not going to be able to do that this year, unfortunately, but I do want to show you some pretty cool stuff about abacuses. So you are probably going to be watching a few little short videos and then watching a video of me trying to tie all of them together. All right, so have a wonderful weekend. Make sure you completed all of your assignments and turned them in today, please. Thank you. See you in the next video. Bye.